assignment is going to teach you guys square and square roots. Please like, share and subscribe our channel to receive our videos in regular intervals on different topics. Let's get into the video now. The concepts that we are going to learn in this video are what is square, about perfect squares, properties of squares and fun patterns of squares. So what is a square? Let's learn that through an example. 1 square is equal to 1 into 1 is equal to 1. This equation shows that the same number is multiplied twice a times. If you observe all the other examples, 2 square is equal to 2 into 2 is equal to 4. 3 square is equal to 3 into 3 is equal to 9 and keeps on going. The numbers, that is the exact square of a number, is known as the perfect square. But how to find a given number, whether it is a perfect square or a non-perfect square? The answer is we should write down the prime factorization of the given number. We should check whether all the prime factors got the pair or not. If it has not got, it is not a perfect square. If all the numbers got the pair, it is a perfect square. For example, let's take the number 256. The prime factorization of 256 is 2 into 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 2. The numbers got the pair. See, 2 into 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 2. Therefore, 256 is a perfect square. Let's see some of the properties of the square. The first property is that a number that has an odd number of zeros is not a perfect square. For example, let's take 25,000. Its square root is 158.113,883,0008. Oh, sorry, I didn't explain what a square root is. Square root of a number is which produces a specific quantity when multiplied by itself. I will explain this in the next video of mine. Now, let's get into the topic. Therefore, 25,000 is not a perfect square because the number does not end and keeps on going. Hence, this condition is proved. The second property is that a number that has an even number of zeros is to be a perfect square. For example, the square root of 2500 is 50. In this, the number ends, so it is a perfect square. Hence, this condition also proved. A third property is that squares of even numbers are always even. For example, 6 square is equal to 6 into 6 is equal to 36. 6 is an even number and 36 also an even number. Hence, this condition is also proved. The fourth property is that squares of odd numbers are always odd. For example, 7 square is equal to 7 into 7 is equal to 49. In this, 7 is an odd number and 49 is also an odd number. Hence, this condition is also proved. The fifth property is that the squares numbers ending with 2, 3, 7 and 8. I again repeat, 2, 3, 7 and 8 are always not perfect squares. For example, the square root of 12 is 3.464101,61514 and keeps on going. So in this number also the number doesn't end, so this is not a perfect square. Hence this condition is also proved. The sixth property is that the square of a number other than 0 and 1 is either a multiple of 3 or exceeds the multiple of 3 by 1. For example, multiple of 3 square is equal to 9, which is a multiple of 3, and multiple of 3 exceeded by 1, 4 square is equal to 14, which is 15 plus 1, where 15 is a multiple of 3. Hence, this condition is also proved. The seventh property is that the square of a number other than 0 and 1 is either a multiple of 4 or an exceeds 4 by 1. For example, 6 square is equal to 6 into 6 is equal to 36, which is a multiple of 4. And in the second example, 7 square is equal to 49, which is 48 plus 1, where 48 is a multiple of 4. Hence, this condition is also proved. The eighth property is that the difference between the squares of two consecutive natural numbers are equal to that of the sum. For example, let's take 3 and 4. They're consecutive, am I right? So let's take them as the squares, which are 3 square and 4 square. 4 square minus 3 square is 16 minus 9 equal to 7, which is 4 plus 3. So you all should remember that n square plus n plus n plus 1 minus n square is equal to n plus bracket n plus 1. This is indeed an important concept. Hence, this condition is also proved. The ninth property is that the square of a number n is equal to the sum of first odd numbers. For example, 1 square equal to 1. 2 square is equal to 1 plus 3, which is 4. And then 3 square is 1 plus 3 plus 5, which is 9. In this pattern, the numbers goes on, and this is one of the easiest ways to find the perfect square. The 10th property is that the squares of natural numbers composed of digit 1 follows in a peculiar manner. For example, 1 square is 1 and 11 square is 121 and 111 square is 12,321. I hope all of them can understand this pattern. Hence, this property also proved. Therefore, we completed the properties of the square. Hooray! The numbers of non-square numbers between consecutive square numbers is 2n, where n is the least number in consecutive pair. Let's see an example. For this, let's take consecutive squares, 6 square and 5 square. Least number which in this pair, which is 5 here. So 2 into 5 is 10. Therefore, there are 10 non-square numbers between 5 square and 6 square. Now, let's end our video. In upcoming videos, we will be seeing about square roots and methods. Until then, it's done. We'll see you in the next video. And don't forget to like, share and subscribe to the channel. Thank you.